Okay, welcome back. This time it's going to be your turn. I'm going to help you understand a few of these problems quickly, and then you're going to be able to work on your own. Remember these pages, these 2 pages in your practice book, by the way, practice book, lesson 8, page 79 and page 80. These are part of your assignment to complete and have completed for tomorrow. Hopefully you have this page with you. If not, the page will be available to you on Canvas, and you can use the annotation to type on there or mark it up if you're able. You can print it out from home if you have that ability, or you can just do the work on paper if you must and bring that with you. So hopefully you have your page, but if not, you have other ways to access this page. So I am not going to do these problems with you. All I'm going to do is walk you through understanding the problems. You can listen to this whole video and I walk you through each one. Or if you'd like, you can pause the video each time I talk about a problem. You can solve it and then you can press play again. So that way you can continue solving those problems. Okay, so the first question that you have says, Fabiola's basketball team practices 4.25 hours each week. I'm going to first remember that I know that 4.25 means 4 and 25 hundredths, or 4 and a fourth. So each week. So if I think about that, let's just say that's basically an hour each day for 4 days. Okay? And the basketball season is 14 weeks long. Oh, so think about that. Week 1, week 2. I'm going to switch it back to decimals. Week 3. Whoops. Week 4. I could keep doing this. What do you see is happening? How much time does Fabiola spend in practice during the whole season? Wow, look at that. I see a lot of repeat addition happening because this would keep going for 14 weeks. Ooh, it says, can I use an area model to solve this problem? Ooh, I'd love to see some area models. That'd be kind of cool. Of course, you can always check your work with old school algorithm math if that works for you. You may choose partial products, area model, old school, anything you need. Okay, question number 2. The model, all right, I see a model right here. The model represents, that just means shows, the expression, that just means the math problem. So in other words, this model shows the math problem 7/10 times 3/10. All right, little area model happening here. Choose the product. Product just means what? So you've got your choices there. It asks you, what does each small square represent in the model? What is just one of those? I don't think it's a tenth. Val chose C as the correct answer. How did she get that answer? So you're going to have to decide if Val was correct or incorrect. So first you're going to need to solve the problem. Then you're going to have to decide if Val has the same answer as you, and is she right or wrong? I would assume you would think she was wrong if you have your own solid answer choice. But then you have to analyze, what did Val do to get that answer? If she's wrong, what did she do incorrectly? Okay. Number 3, find the product of 6/10 times 6/10, or 6/10 of 6/10. You can even think about it like an area model like that one. Will the product be in tenths or hundredths? Ooh, 6/10 of 6/10. Kind of reminds me about what happened up here. Will the product be in tenths or hundredths? You might be able to solve that problem without even doing any math and just using logical thinking. Of course, you can always Check your work down below. Okay. Number 4, move this up. 1 pound of red grapes costs $2.42. All right. If you know me, you know I like to draw stuff out to help me understand the problem. So if this is going to be a pound, it's saying that if I get the whole pound, it costs $2.42. Ella buys a half a pound. Oh, she buys half. She's only going to buy this much. How much does she spend on red grapes? Look at this guy. Will the product or the answer to a multiplication problem be greater or less than $2.42? $2.42 was the cost for the whole pound, but if you remember my drawing, it says that she bought half a pound. So half of $2.42. Half of. Kind of reminds me of some stuff we talked about up here and here. Something to think about. You've got lots of space down there to solve your problem in any way that works best for you. Okay. And number 5, last one. Terry lives 9/10 kilometers from school. 9/10. That's almost 1 whole kilometer. So if he lives here and school is here, look at that. This would be like a whole, 1 whole kilometer. But he lives 9/10. So from there to there is 9/10. Okay. He walks back and forth to school each day. So let me think about that. Each day he goes to school 9/10, back home 9/10. So one day he goes to school and home from school. 9/10, 9/10. There and back. Okay. He walks back and forth to school each day. How many kilometers does he walk to and from school each week? Well, I'm pretty sure the drawing that I just made would show you how much he would go in one day. So this might be a multi-step problem because now we need to know how much he would go in a week, and we need to remember how many days in a week Terry goes to school. I'm pretty sure we don't make you walk to and from school on Saturday and Sunday, so something to think about. All right, you can solve those problems. If you have any questions, you can always reach us by email, but remember, we're going to be going over some of these things when you come back to school tomorrow. So if you've got some questions, kind of jot them down on your paper and we can go over them at school. Just do your personal best.